Okay, there are a lot of obvious stuff you're going to hear. There are also a lot of lessons learned from the work that we're currently doing at Critical, and Critical is kind of the important bit in our name. And just to give you a little introduction on who I am. So you had Abby was from a mathematics background, I guess. I'm from physics. I took forensics. I went for a PhD and then regretted the whole time. I worked at AWS, as I already said, and I basically divide my career into two ways. And the reason I'm telling you this is I think it's very important because my focus before AWS was in breaking things in clever ways, automating things, scaling things, breaking. And then when I came to AWS, it was about building things that didn't break. But you did have a saying at AWS that everything breaks all the time. Now, this seems kind of paradoxical because I don't know does anyone know what a critical system is? Who knows what a critical system is? Okay, great. So basically, a critical system is a system that is not supposed to fail. So if it fails, human lives are at risk. Okay, you can have an ecological disaster. You can have a business impact, and well, basically a lot of shitty things can happen. Okay, so and it's kind of paradoxical, right? On the one hand, we know things are going to fail, but you're also trying to build things that shouldn't fail that often, right? So my role is principal AI engineer. Okay, I'm trying to shy away from the stereotype of a principal AI engineer. Okay, so if I ever get to the point where it's just Excel and PDFs just should be in the face, the way I approach this role is mostly around the principal engineering community tenets we have at AWS. This is public stuff, by the way, and it's a very interesting reading in case that's where you're aiming in your career. And also, I contribute a lot to open source. This is kind of my go-to at AWS. This what gave me pleasure. Martin knows this because he also contributed some of our AWS community talks. So if you want to check out some of the things we do, you can go ahead and go and do it. I did contribute to LangChain. Okay, there's going to be a mention of LangChain, but I've come to hate LangChain for several reasons, and I'll get to tell you a little bit why. We do have a public repo called the Safety Critical AI. It's an awesome repo, okay? It's publicly available. We're looking for contributors. It's kind of fun. There's a lot of great things in there. And if you contribute, you can have your name in the citation. So be part of a community that's building this stuff up. There's a lot of great things there. You have plenty of time to go at it. So what is the agenda for today? I'm going to talk a little bit about the importance of red teaming. Just keep eating. Don't worry. So the importance of red teaming. And there's a long tradition of red teaming. And you want to reuse some of the lessons learned of red teaming traditional systems, and you'll get to see what I mean in a second. Understanding what exactly are large language model vulnerabilities. And by the way, I'm going to focus only on text. There are a lot of cool attacks using images, multimodal, but that's not what I'm going to do because I only have 30 minutes and everyone will kill me if I go a little bit over time. We're going to talk a little bit about how we approach the problem, okay? What tools we use, which techniques are the best, some case studies. I added case studies with actually oral stories. So you're going to see a little bit of what could go wrong if you don't test the systems. And finally, the discussion and Q&A is just there for the lols. Okay. So the importance of red teaming. Why are we talking about this? Why am I giving this all? First of all, LLMs are getting real. Okay. And I used to joke that we could go, when I was at AWS, I would go with a customer. We will build an application, a POC in 15 minutes and call it a day, right? And then they would work for a month, 2 months, 3 months, and the thing would be reliable enough to put in production. Okay, so there's the 1%, the thing that makes the system actually production ready, takes most of the time for us, right? So they're being used in real world applications, and you've probably seen some of these cases, right? Character AI, we had a teenager that was killed because there was a little bit of role playing, and he got a little bit too involved. We have, for instance, car deals for $1. I don't know, that Wheeze you see over there, that's the company Google is trying to buy. They found a vulnerability in DeepSeek chat, right? So basically they're exposing every information out into the world. And this is kind of basic stuff, right? Everyone that builds this kind of applications, connects with a ClickHouse, knows that you should protect that. You shouldn't open that to the world. So I think there are a lot of lessons learned from cybersecurity. They're not being added to the AI community. And I think the divide is mostly because of the lingo, the difference in technology, the uncertainty also, and the things are evolving so fast. I was talking with Abby after the talk. It's kind of hard to pinpoint all the evaluations, all the metrics that we have, and it's, well, creating a presentation out of that is kind of impossible, right? So we need to focus on security because we're going to scale to millions, probably billions of people, billions of users, and if you don't do that, the result is critical damage, okay? But I don't know, who has done a red teaming exercise? Just to, 1, 2, 3, 4, 5. Okay, that's good enough. So red teaming comes from a long tradition in cybersecurity. Actually, it started with military training, but it's evolving very rapidly. So it's adapting to the AI concerns, right? But the basic idea is that you have a team that is going to play the role of an adversary, and they're basically going to attack the system from the outside, okay? Now we're going to chat a little bit about what that means, right? So first tip, okay? When you're doing a red teaming exercise, just make sure that you get it in writing, okay? Make sure that you have the authorization to do so, okay? I've seen some very nasty stuff, okay? And the idea is that you're going to identify risks, okay? Assess the vulnerabilities, propose mitigations, and make the system more secure, right? Now the big issue, and I'm shying away from the camera, sorry. The big issue is that GenAI has basically maximized the attack surface, right? And there are a lot of things for which cybersecurity teams are not really prepared to address. So, and that's why I'm giving this talk. So I usually think of this as basically you're going to interact with the system, like in a kind of a Jenga, and the goal is to make it go ablaze. So I'm going to give you just a little bit of an idea of what could go wrong, okay? And there's a very good database of AI incidents, and you can see even a distribution of the things that are usually being exploited in these cases. Okay, something missing here. Okay, I'm going to give you in a second, because this changed a little bit. So I'm going to give you a couple of examples. We're going to talk a little bit about vulnerabilities, but I also wanted to connect with the talk that we heard from Abby, right? And that's really the connection between red teaming and safety and security testing, benchmarks, and the differences between what an LLM application is and the model, okay? We're not talking about just model testing. There's a lot of things that are involved. So we already heard Abby about this. So benchmarks are going to test performance, okay? And we heard a couple of examples, right? We have MMLU that basically measures multitask accuracy. We have LSWAG for common sense. We have, I think, Big Code for programming abilities, and ARC for image-based breathing, okay? And plenty more. This keeps evolving, okay? And the shitty thing is that people don't maintain this kind of stuff. So you get a metric, and then no one is going to work on that for a couple of years. What benchmarks don't do is test safety and security. And I can give you an example. So check this example from MLU. Do you think this is testing security? Obviously not, right? This is just a complex geometry, like complex analysis problem. This is not security. So we need to go a little bit further than this. Now, the difference between an LLM application and a foundation model is that there are obviously shared risks, okay? Toxicity. We have criminal activity that is being promoted by the use of LLMs, right? Spam is galore, right? You've probably seen that the emails are no longer from a prince of Nigeria somewhere. They've evolved a little bit. We have obviously bias and stereotypes, privacy, data security. So this is common stuff, right? But then we have unique application risks, like inappropriate content, out of scope. I think Abby mentioned this, out of distribution behavior. We have hallucinations. We have sensitive information disclosure. And I want to give you a couple of examples of some of these. So let's start with hallucinations, okay? This is kind of fun, right? So this comes directly from the AI incident database. And basically, we had a plaintiff that, well, basically hired the services of lawyers. And they basically created a case. And they used ChatGPT to write the documents. And basically, the judge says, you must verify the sources. Because in the actual, I don't know if you can see this, but basically, none of the references existed. I think he had like 9 references and only one existed. And it's not fully correct, right? So it's kind of interesting to see a judge giving tips on how to prompt these models and verify the content. But there you go. This one, I think is one of the scariest stuff I ever seen, okay? So this one is from a call center, AI-powered call center.
Is there a way to zoom in somehow?
I don't think so, but I'll give you the slides. I'll give you the brief, okay? You just need to see the scary stuff. The images come later, and you'll see what the scary stuff is. So basically, there's a management dashboard for this application. So we're not talking about the model, we're not talking about the endpoints, we're talking about the dashboard which we use to control what's happening within the application, okay? And basically this was exposing 10 million conversations, okay? This is the dashboard, pretty evolved stuff. They basically exploited access to this dashboard. They sold data on the dark web, okay? Well, and you can tell from the avatar, this is the dark web. And then they basically just share data information from IDs, national IDs, okay? And to top it all up, they use OCR to extract information from the images, the IDs, and then share that information, okay? Very good. 10 million conversations. Just think of that. Sorry? Which app? I think it's a call center in Dubai, okay? So if you hear the words AI-powered call center, just run. Now, we've been talking about vulnerabilities and exploiting, but actually the work starts a little bit earlier than that. And it starts with weaknesses. So what are the weak points, right? Where are the points of failure for our system? And I just wanted to give you a little bit of what you're trying to do also at Critical. So we're part of this CWE AI working group. And one of the things that we do is basically, I don't know if I can share this. Yeah, and we basically discuss this. So if you go to CWE, so probably a lot of you have heard of CVE and CWE, a lot of the specifications that you see are actually our contribution. And I can tell you that the discussions are very funny. So the last one was about whether we should call inference parameters or hyperparameters. And we spent like 20 minutes on this. It was very good. But it's something we have to discuss, right? Another one, this is a very good one, and the reason I'm getting this is because I'm going to show you a slide of some of the things that we used to do at AWS. So this is the OWASP top 10. Who has seen the OWASP top 10? Nice, great. So this is the top 10 vulnerabilities. We talk about vulnerabilities, not weaknesses at this point. We're also contributing to this project, basically supporting capacity, so basically review the documentation. We do not actually write the documentation. And just to give you an idea, so we have the top 10, okay? Things like prompt injection, we have sensitive information disclosure, we have misinformation, right? So I wanted to give you, so this is not my slide, and I want to say to the camera, thank you to my team at AWS for allowing me to use this slide. I adapted a little bit so it's not like the same style we usually have at AWS, but this is the standard application, right? We have the users connect to some kind of API, in this case an API gateway, and we have Bedrock, which is like OpenAI at AWS. We have agents that are going to call models, that are going to connect with the vector database, and they're basically going to do a lot of stuff. We're going to see a lot of shit with a Lambda function, like connecting to a database or external APIs, or even send messages that are going to be processed by other systems, right? Now, one of the things that we do, and we start with the infrastructure, is we're going to model risk, right? So what are the risks? I'll give you an example, right? First one, big one, prompt injection, right? So and this one is kind of funny because anyone can do this, right? One can just go to a website, type a prompt, and you can exploit the system. That's it. But something you might not have heard is that you can actually do indirect prompt injection. So when you're indexing the files for a vector database, you can actually poison our vector database, which is kind of fun. There's also sensitive information disclosure. And sorry for the formatting. I fixed this before you came here, but this is not up to date. So we have sensitive information disclosure between when we send data to our data lake. This is the case, S3 bucket. We have sensitive information disclosure when you connect with the agents, when you connect with the vector database. But this keeps going on and on, right? We have, if we're not parsing things correctly, we can get things that doesn't make sense when you connect the agents integrate with the Lambda functions. We can have excessive agency. This is my favorite, right? This is basically giving too much power to a Lambda function. I've never heard of this, but this is kind of fun, right? So this is the kind of stuff you have to deal with, right? Now, what do we actually use to address this kind of things? So well, honestly, the title is just because I love alliterations. Don't read too much into it. One of the things that we do, and by the way, we were preparing, I was talking with, I think it was Alex, we're preparing a red teaming exercise at Critical. We're going to pair up cybersec with our AI team. And one of the things, the first thing we did, so we set down a couple of questions, okay? These were actually adapted from that article, which is very good, right? And this is very important stuff, right? Again, make sure you have it in writing, make sure you know what you're testing, how you're modeling those threats and risks, what if you're targeting specific things, right? I think one of the biggest mistakes is that people are going to try to tackle everything, right? They're going to take the best tool for the job, and they're going to bombard the system with prompts. That's not the way it works, right? There's a lot of ingenuity and creativity involved in this kind of exercise. How will we know that we've achieved our mission, right? Who will be part of the team? Sometimes it's not just about the AI team, and you'll see what I mean in a second. What do we have available? What are the rules of the game? Which access do we have? What is in our arsenal? What can we actually use? Can we use automated tools? Sometimes we can't use automated tools because you're impersonating an actual user, right? And an actual user is not going to use, I don't know, pirates or something. How are we going to generate the results and share them? What are you going to consume? So we talk about the resources, but sometimes we don't need the full thing, right? But you'll need time. We'll need compute. We'll need to invest a little bit of money, right? Red teaming exercises are expensive, I can tell you. And we'll need a lot of knowledge, right? Because you're going to talk with a lot of people before you sort the exercise. So there's a lot of things, right? And I think this is one of the most obvious things that people don't usually take for granted, is basically that failing to plan is planning to fail. And this is especially applicable for red teaming exercises. So you really need to plan. You really need to address carefully what you're going to involve in red teaming exercise. Now, Microsoft, I think, is miles ahead in this kind of thing. They have this cool ontology for AI red teaming exercises. If you've ever done a red teaming exercise, you'll look at this and say, well, but that's just a regular ontology. What's the difference, right? So you have the actor that's going to do an attack, that's going to leverage TTPs, that's going to exploit weaknesses, and then basically these weaknesses occur in the system, and then you're going to measure impact and then propose mitigations. That's just regular red teaming exercise. But there are some differences, and I just going to speak about one, which is, for me, it's kind of interesting, right? Is that the actor's intent. Usually for a red teaming exercise, we're just assuming that they want to attack the system, that they're adversarial, but that's not usually the case. So you've seen cases where people exploit weaknesses in the system inadvertently. So they go into the system, they interact with the application, and they basically exploit the system, right? Now, in the same paper, they have some cool lessons learned. And honestly, I think they were spot on in some of them, but, well, some of the lessons are more important than others, right? For me, I think the most important one is that, where is it? I have to find it. This one is the most important, right? Because there will be a lot of creativity, a lot of ingenuity involved in this red teaming exercise. And also, well, this is kind of obvious, right? But we have to say it. And automation, I mean, it's important, but it's not what's going to tip the needle on a red teaming exercise. And I think there's one, this one. This is kind of interesting because a lot of people will tend to overcomplicate the attacks. And what's nice about this is that you can actually attack the system with something very, very simple. I think elegance is in the simplicity of the attack, right? And well, we're engineers. We're proud of the things that we do. We want to showcase that we're very smart, and we can concoct some kind of prompt that's very complex, that will add a lot of information, that will use some kind of encoding, but that's not really what we need. We can just take the system for what it is. Just a user app is going to interact with the model, and that's enough, right? Just doing some simple prompts, that's usually enough to tip the scales in our favor. Now, I want to talk a little bit about automation, right? So this is important. And our team is, it's lean. I don't want to say small, but it is lean. And, well, this exercise are very consuming. And, I mean, we work in all kinds of critical systems, right? Energy, defense, security, healthcare, space, avionics. We can't go everywhere. So we have to rely on automation. But there are a few things that I'd like to mention about this. Obviously, you can still have manual injection techniques. Usually, we'll all have some kind of library of prompts. You probably have a repo on GitHub with a list of prompts that you usually use, and then they're fine. And you can use scanning tools, okay? The scanning tools, they're very interesting prospect, but a lot of them are not stable enough to be used in this kind of exercise, right? And for the most important thing for a critical system is that it can give assurances that the thing actually works, right? So it's not just that I ran the script and it worked great. It passed all the tests. That's not enough, okay? We have to assure the client, okay, the user, that this will actually be deterministic, okay? And we always have to keep the human in the loop. That's a given, okay? That's not an option to say, hey, it's fully automated. Critical systems, That won't cut it. Now, I just wanted to give you a little bit what my sources are. Well, this is I added some which I didn't know before the presentation, but I think they're very good. The best source ever for prompts, Twitter. Okay, best source ever. Okay, just scrape Twitter, get all the prompts, and you'll be fine. You'll have a very good library of prompts. Pliny the Liberator, probably heard of the name. He's very good. He has a lot of exploits. He pawns models every time. This one is also very good. I haven't used it that much. This one is a good collection of different tips. So it's not really prompts. It's things you can add to the prompt that will tip the scales in your favor. Right? Now, sorry, I don't know if it was a question. I just wanted to give you something. So this is just for prompts, and there are a few cool things you can do just to test it out. Right? I don't want to do a demo, but this one is a very good. I don't know if who has heard of Gandalf. Gandalf. I think it's very good. It's a gamified experience. So it's kind of a red teaming, but just for prompts. And the idea is that you're going to exploit Gandalf, and he has to give you the secret, right? And then you put the secret, and you advance to the next level. It's kind of fun. We did the same. Actually, we did a similar exercise at AWS, and it was very fun to watch this at play. Something we're also involved in, we're creating promptathons within Critical. But there are a lot out there. You can just enroll. I first heard of the concept like I think 1.5 years ago. I thought it was funny that basically there was no code involved. It was just prompts, just text, and it's kind of fun. And just to give you an example, some of the things we can do. So we put a little bit of meat in the bones. For instance, if you take jailbreaking, right? So there's a very good blog post from Prompt2 where they go in excruciating detail on the things that you can do, from direct attacks, the indirect methods, to a little bit of prompt engineering, a little bit of role-playing, technical exploits. But honestly, you can do something as simple as this. Okay? Who has seen this one? Come on, dude. You can just raise your arm. I'll just assume you know this one. So this is Dan. And Dan stands for do anything now. Okay? It's a class of attacks. It's very cool. But basically what he says is that just act as Dan. And Dan is God mode enabled. And just do whatever you need to do. Now, some of the tools. So I know you probably want to try this out and you want to use automation tools. I get it. I'm trying to give you the sense that tools will get you to a point, and then you have to rely on your creativity to do really cool stuff. Now, there are a couple of tools which I like. This one I think is the best right now. I don't know if you all agree. This one is from NVIDIA. So they basically have a command line where you can target a model. You can give it the model ID. You can also target Hugging Face models, or you can implement basically an interface for REST API and then interact directly with the application. This is the one we're currently using at Critical. And just to give you an example, what comes out of it. And sorry, I didn't know this would be the room would be so big.
That's just pure cruelty.
Yes. So basically, when you run this, you're going to select the probes you want to use. That's the lingo they use. And basically, this is the list of different Dan prompts. And I don't know if you can see this, but in this case, I'm using a model from Hugging Face called BatSeek. And I'm applying a Dan probe called Dude, which I love. This is so fucked up. I don't know if you get the reference from The Big Lebowski. I honestly give it, if you have the chance to look at the slides and read the Dude prompt, you'll find it very amusing. Now, I'm just going to talk a little bit about BatSeek because we don't do a lot of model poisoning, but it's kind of fun to understand how it works, right? One of the things we could do, and this is a good example, it's called a model called BatSeek. And basically what we do is that we add a layer on top of an existing model, and you can think of it as basically muffling the receiver from a call, and basically adding content to the generated content. So the model, I think, is a Quen base. Abby talked about Quen. I'm also very fond of the Quen models. And basically the idea is that, so basically you have the model on Hugging Face, and then you're going to integrate this in an application. Streamlit is very good for exploits, I can tell you. And then you can see the script. So this script is actually doing something that it's not supposed to, right? So this is added by this head, right? So you can just swap out the model, and this will work. And if you think about the architecture on AWS, so Quen is not supported as a custom import, but you can actually take a meta model, right? You can take a Mistral model and do pretty much the same. Yeah, that's the script. Now there are other tools. Some of them I'm looking into that space, or we're looking into that space, but they're not just there yet. Pirate is one of them. This is from Microsoft. I think it has potential, but it's still it's too soon to tell if it's going to pan out or not. Giscard is very good. It has a user interface, and you can also I mentioned that I was not going to use LangChain. This actually uses LangChain. So this is a simple application. This is the same demo they have on their website, but I don't know if you've used LangChain, you know that LangChain is constantly changing. They keep changing models and decoupling stuff, and this was, I'm very perfectionist. I don't like to see code that has a bunch of deprecated warnings, so I changed the code to use UV, okay, and basically change the whole thing to work without deprecated notices. So you're welcome to try it out. Now, key takeaways, and I think I'm so over time. Key takeaways. So AI red teaming is evolving, okay? And if you're acquainted with traditional red teaming exercises, you'll know that this is true. There are no tools yet, in my opinion, that address the concerns of both the AI community and the cybersecurity community, but we need to adapt fast, right? The LLMs are out there, right? They're already working on your applications. Some of you probably have LLMs or SLMs running your mobile phones right now, right? So we need to address this. Again, failing to plan is planning to fail. So we need to prepare this kind of exercise, right? And again, put it in writing. You keep it simple, right? But keep it simple as possible, but not simpler, right? Sometimes you do need to get a little bit overboard, but sometimes you can go a long way with just simple attacks. Finally, leverage automation at scale, but just keep in mind that a tool is only as good as one who wields it, right? And finally, that we're just scratching the surface, right? There's more that we don't know, right? There's the famous quote called, "What we know is a drop, what we don't know is an ocean," right? This is true for security, and this is true for merging GenAI and foundation models with traditional applications, right? So this is a very complex arena, and I welcome your feedback from the presentation. This is the first time I'm giving this one, so if you have any questions, I'll give you the slides, and you have plenty of references to go around. Yeah. Thank you so much.